welcome to this session. Today, we will explore full adders, an important part of digital logic. Knowing how full adders work is crucial because they are used for complex math in digital circuits. Let's learn more about full adders and why they are so important.
Objectives. At the end of this session, you will be able to construct the full adder circuit with two half adders using ICs and verify the truth table, and familiarize with the operation of a full adder circuit. You will need the following tools and equipment such as digital trainer kit 1 number, digital multimeter with probes 1 number, wire stripper 1 number, and tweezer 1 number. You will also need the following materials and components such as IC 74001 number, IC 7486 1 number, hookup wire as required, and datasheet for ICs. It is important to learn the concept of full adders. A full adder circuit is a key part of digital logic systems. It is designed to add three binary digits, two input bits A and B, and a carry-in bit C in. Building on the half adder circuit, the full adder allows the addition of multiple bits, considering the carry-in. When you use a full adder circuit, it gives you two results, a sum bit S and a carry-out bit Cout. The sum bit shows the outcome of adding the three input bits, and the carry-out bit tells you about the carry generated during the addition. By connecting several full adders in a sequence, you can carry out complex arithmetic operations with precision on binary numbers. The output equations of the full adder are: looking at the truth table, we can see that the sum output S results from the XOR operation involving input Cin and the half adder's sum output considering inputs B and A. The carry-out Cout will only be true when at least two out of the three inputs are set to high. Let's now dive into the procedure of construction and testing a full adder circuit using two half adders. It involves the following steps. They are: Step 1. Inspect the components and set up the breadboard. Step 2. Connect both the IC power pins to plus 5 volt and ground. Step 3. Attach switches for different levels to input. Step 4. Connect both the outputs of ICs to an LED. Step 5. Test the circuit by toggling switches. And Step 6. Observe and record the readings. Let us now look at each step in detail. Once you are ready, collect all the required components and check them to ensure they are in a good working condition. This includes both 7400 and 7486 ICs. The digital trainer kit, which includes the breadboard, power supply, toggle switches, resistors, and LED. Once you've got everything, mount the two 14-pin ICs firmly on the breadboard. You can use the circuit diagram for reference. Connect the plus 5 volt power supply to the positive terminal of the breadboard. Next, connect the 14 pin of both the ICs to the plus 5 volt power supply. Also connect the ground of the trainer kit to the negative terminal of the breadboard. Then, make sure pin number 7 of both ICs are connected with the ground. Moving on to the inputs, connect the toggle switch S1 to the first pin of IC 7486. And fifth pin of IC 7400, which corresponds input A. Connect switch S2 to the second pin of the 7486 IC and fourth pin of 7400 IC, which corresponds input B. Also connect switch S3 to the fifth pin of 7486 IC and second pin of 7400 IC, which corresponds C in input. Interconnect the third pin of IC 7486 with fourth pin of the same IC 7486 with the first pin of IC 7400. Feed the outputs of 7400 IC from 6th pin to the 10th pin of the same IC and pin 3 to pin 9 of the same IC as inputs. The final sum output is obtained from the 6th pin of IC 7486 and the carry output is obtained from the 8th pin of 7400 IC. Also ensure the switches can toggle between the 5V for a logic high and 0V for a logic low. According to the logic levels, you will test as shown in the truth table. This will help us to see the result of the full adder circuit clearly. Before you power up, get your assembled gate circuit checked. With everything checked, switch on the 5V DC supply. Begin the test by operating switches S1, S2, and S3. Watch the LEDs closely for each setting. It should light on or off to indicate the output levels. Test all possible combinations of inputs A, B, C in. Toggle the switches S1, S2 and S3 between high and low states for testing all the combinations. When switch S1 is set to low, switch S2 is set to low, and switch S3 is set to low, the output of the sum LED should be off and carry LED should be off. When switch S1 is set to low, switch S2 is set to low, and switch S3 is set to high, and the output of sum LED should be on and the carry LED should be off. When the switch S1 is set to low, switch S2 is set to high, and switch S3 is set to low, the output of sum LED should be on and the carry LED should be off. When switch S1 is set to low, switch S2 is set to high, and switch S3 is set to high, and the output of sum LED should be off and the carry LED should be on. When switch S1 is set to high, switch S2 is set to low, and switch S3 is set to low, the output of sum LED should be on and the carry LED should be off. When the switch S1 is set to high, switch S2 is set to low, and switch S3 is set to high, and the output of sum LED should be off and the carry LED should be on. When switch S1 is set to high, switch S2 is set to high, and switch S3 is set to low, and the output of sum LED should be off and the carry LED should be on. When the switch S1 is set to high, switch S2 is set to high, and switch S3 is also set to high, the output of sum LED should be on and the carry LED should be on.
This brings us to the end of this session. In this session, we have learnt construction of full adder circuit with two half adders using ICs and verification with its truth table and familiarization of the operation of a full adder circuit. Thank you for watching. We will see you in the next session.